Okay, example 57 is about indeterminate thrust, approximate analysis of indeterminate thrust. Determine the axial forces in each of the counters shown below. Consider two cases. Case A, counter diagonals can resist both tension and compression, and letter B, counter diagonals are made of ropes. So this is the figure, summation moment about D equals 0. Then vertical component at A times 15 equals 60 times 5 plus 40 times 10. We'll get RA is 46.667 kilonewtons upward. Likewise, summation moment about A equals 0. RDY times 15 equals 40 times 5 plus 60 times 10. You'll get RDY equals 53.333 kilonewtons. RDX is 0. Obviously, there's no inclined load. So it is 0, not shown in the figure. So the panel shear in HD should be 46.667 downward. Then in BC, 46.667 minus 40, so it should also be downward 6.667. And these are the expected forces. The force in BH should be down, the vertical component should be downward because the panel shear is downward. The vertical component of AG should also be downward. So BH is tension, AG is compression. And this is the slope, 5 horizontal, 4 vertical, square root of 41 hypotenuse. In panel BC, the shear is downward also because this is 46.67, this is only 40, so 6.667 downward. So the force in CG is tension, and the panel shear in CD is 46.67 minus 40 minus 60, so it should be upward plus 53.33, or 46.67 plus 53.33 minus 40 minus 60 is 0. So it should be upward if we analyze it from left to right. But if you analyze it from right to left, then this should be downward. And if it is analyzed from right to left, the forces will be the same. So it's DF should be in compression and CE will still be in tension. So we then, by assumption A, we then equate the vertical component of FBH to half the panel shear, or 0.5 of the panel shear. So vertical component of BH is FBH times 4 over square root of 41 equals 0.5 of 46.667. So FBH is 37.35 kilonewtons tension. Because the counter diagonals are symmetric, then FAG is also 37.35 kilonewtons but in compression. We then proceed to panel BC, so FCG is tension, FBF is compression. So by assumption A, the vertical component of FCG, which is FCG times 4 over square root of 41, is equated to half the panel shear, 0.5 of 6.667. So we get FCG 5.36 kilonewtons tension. Automatically, by symmetry, FBF is 5.36 kilonewtons compression. We then proceed to panel CD. In panel CD, DF should be compression while CE must be in tension. So let's compute FCE. Vertical component FCE times 4 over square root of 41 is equated to half the panel shear, 0.5 of 53.333. So FCE is 42.69 kilonewtons tension, and FDF by symmetry is also 42.69 kilonewtons compression. Then by assumption B, counter diagonals are made of ropes, so all these compression members must be 0. So FBH, vertical component of FBH, is equated to the panel shear because it is the only one that is active tension diagonal which will resist this panel shear. So it is now 74.7 kilonewtons tension, while FAG is 0 automatically. Then FCG times 4 over square root of 41 is 6.667. So FCG is equal to double the first, so 10.67 kilonewtons tension, while FBF, which is in compression, by assumption B, is 0 because it is in compression. And lastly, FCE this time is in tension, so the vertical component FCE times 4 over square root of 41 is equated to the panel shear 53.333. So FCE is 85.37 kilonewtons. Automatically, FDF will be 0. So that's it for this problem. And I hope that you can master the principle. It's very easy.